All right. I don't know if we're still missing a few people. Kind of looks like, but we're going to get going. Okay, so first off today, I really hate how Zoom, like this box I'm dragging around right now, that's the chat. And Zoom, at least on this computer that I'm using, it doesn't just make it transparent. It's like that box. Kind of annoying. Okay, so today we're going to be doing the quiz retake or whatever you want to call it. For quiz 2, it's going to be on the same stuff as last time. In fact, it's very similar to last time. I pretty much kept all the questions, except I changed, some of the values, or I changed exactly what we were, like something we were doing in that problem. So it's very similar. So if we're in student view, just like, every other time we're going to go to quizzes, and it's going to be called Quiz 2 Arrays Revamp. And it's going to be available at 10:55. So you have 20 minutes to work on the quiz. And again, I made sure that it was 20 minutes this time. So if the timer is messed up again, like last time, it's not my fault. It's Canvas's fault still. So hopefully they fixed that issue with the timer. I think they did, but I also didn't get any announcement that it was fixed. And something different this time. So for the quiz before, I've told all of you that you can't use MATLAB or anything at all. That all you can do is, type in your answers for the quiz. But I was thinking about this a bit more, and basically that's too hard to enforce. So maybe some of you were, abiding by that rule, but I can't make sure that all of you are. So instead, I'm going to allow everyone to use MATLAB, and you can use the lecture slides. So that should help you, but at the same time, you still have that time restriction. So you're better off still knowing what, you actually have to do from the get-go. And I also specify this at the top of the quiz. So it says that you can use MATLAB and you can use the lecture slides. So I'll try to remind all of you right before we take the quiz that you can do that too, since that's different. Okay, any questions on the quiz? Okay. All right, so we're gonna continue on with plotting today. So where did I put my slides here? Okay, so we're gonna start out with a little review, like we always do. So we're just gonna make a simple plot. I didn't make a slide for this, so we'll just type something in MATLAB itself. So this was from last time, this code here. I'll actually make a new script. So again, we're gonna be using a script file. So if you don't already have one open in MATLAB, go on this kind of home tab right here and go on the top left, click on new script. All right, so let's plot some function here. We're gonna go, I'm just gonna write some comments so we know what to plot. We're gonna make an X domain from, let's do -5 to 15 with a step size of 0.01. And we'll plot some function y equals e, actually we want to just kind of write this out as a math equation, e to the 0.2 times x minus 5x squared, sure. And you're going to put an x label, a y label, and a title. Let me make my font a little bigger. I don't know if it's a little small. fonts. Okay, so I'm going to give you guys a few minutes to work on that. So yeah, I just typed it out. So in X domain from -5 to 15 with a step size of 0.01, a function y where that's e to the 0.2x minus 5 times x squared. I want you to have an x label, a y label, and a title. Okay, so hopefully all of you are done. If not, well, we're going to just get going. Okay, so first thing we have to do is make an X domain. Actually, I'll first make a comment here. Also, if I put 2% signs, then in MATLAB, that makes a little section. So you see, once I put in 2% signs, this lighter box shows up, and basically it kind of blocks out a little section where I have these 2% signs. So I'll just call this review exercise so I can look back on it later on and know what I'm doing. Actually, I want to put all of this there. Okay. And also at the top of the code, I'm going to clear the memory. Memory. Clear. Okay. So first thing we have to do is make an X domain. So we're going to do X equals -5. We have a step size of 0.01 and we're going to 15. Next, we have our function. So we have a function or an equation that's a function of X. So we're going to do e to the 0.2 times x minus 5. And first, I'll just do 5 times x squared. And if I just have that, I should get an error. Okay, so I'm running it. Now it's asking me to save it. It's the 30th, right? Yeah. Okay, so yeah, if I just ran that right now, it gives me an error because I'm raising x to a power of 2. X is a row vector, and because it's a row vector and I'm raising it to a power, I have to do that element by element. So we're going to put in a dot right there. And now it should work. Yep. So that code works now, but of course we want to plot it. So we're going to use the plot command. Our first argument is going to be the x-axis. So I'm going to put in x, then comma y. If we just do that, then we get our plot here. But of course, we want an X label, a Y label, and a title. So we'll type an X label and put in a left parentheses. And when we're typing in our labels for the X label, the Y label, or the title, whatever we want to be that label, we have to enclose it in apostrophes. So we have one apostrophe there, and we have another here. Then we're going to close out the X label with another parentheses. So everything within these quotes right here, these or apostrophes, this type of basically I don't know, syntax that we're using, it's called a string. So maybe some of you are familiar with that, but it's a string. So it's an an actual word that we're typing out. So we want MATLAB to read it as a word and not like a function or a command. So we're putting it inside of apostrophes. MATLAB is a little inconsistent because you'll see later on we're also going to be using apostrophes to kind of specify other things in the plot as well. Okay, so we have our X label, and then again we have our apostrophe. So we'll call it I don't know, just X domain, and then I can do comma Y label. So putting comma and then Y label, I can specify the Y label here in the same line of code. Or I can call it, I guess, our function. And then I could also put comma title on the same line as well. And this is my title. Now if I run it, and there we go, we see we have our X domain label right here, our function label, and then this is my title. If I want the Y label and the title on their own line, I'll just delete the comma and then put them on their own line, can run it, and then we get the same exact output. So any questions on this exercise? All right. So we'll also add a legend to this because we talked about making a legend as well last class. So we'll go through this kind of as a class. So to specify a legend, we have to use the legend function or command. So we're going to type in legend. And just like with X label, Y label, and title, we're going to use apostrophes here. So the first argument, or the first thing that we specify in our apostrophe, that's going to be the first kind of text that's displayed in our legend. So in this case, we only plotted one function here. It's just y equals e to the 0.2 times x minus 5x squared. So we'll type in this function here because that's the only function that we have. So we're going to do exp for e, and then we're going to put inside of that 0.2 x. So you'll see here, I'm basically going to type it basically as we would see it, like if we wrote out or typed out a math equation. So actually I have to delete that. So we're going to just type in E. Okay, because now we don't need to have this interpreted as MATLAB code. Again, we're typing it out like a function that we would actually, write out by hand or type. Okay, so we have E. And I'll first show you the incorrect way. So you'll see what I'm talking about, but I'll do e to the 0.2 x and then minus 5x squared. So if I just do that for now, let's plot this. So we have our legend. It might be kind of small on your screen, depending on the size of your monitor, but you can see that the legend here, we have e to the 0 and then 0.2x, that goes back down. It goes back down as like its own number. And obviously that's not what we want, so we got to fix that. So if we have some value and it's raised to an exponent, and there's more than one digit inside of there, or there's more than one, digit or letter, we have to enclose it in curly braces. So I'm going to do E, and then I'll put the little exponent symbol, and then I'll use a curly bracket, and then I'm going to enclose that entire, exponent inside of curly braces. And then if I run it now, then I have e to the 0.2x minus 5x squared. 0.2x, all of that is raised to a power. So that's just like we want it. Okay. Any questions on making a legend? Okay. And another thing we can do with a legend that we talked about last time was we can specify a location. Just I think we talked about this last time. Sorry. So we just type in location. That's going to be basically the first argument that we have for the location of our legend. So we type in location and make sure you put in a capital L because capitalization does matter. And then we're going to put our actual location that we want. So let's say we want to do, we'll do northwest. And you'll see for this, all of this is in lowercase. So again, make sure that you're typing it out with that correct capitalization. We'll run that code, and then now our legend is automatically in the northwest corner. And if I want to move it later, I can click and drag it wherever I want. All right. So that's our little review there for making a simple plot. Let's actually also go over having another curve on the same plot. Little review. So I'll just define another function here. I'll call it y2. And let's make this one sine of 3 times x. Okay, so that's fine. I define that function, and if I run the code, we just have the plot that we just plotted. Let me move these. Yeah.
I sent you 2 pictures. They're not like it's not allowing me to run the file on Discord.
Did you send it on Discord or something?
Yeah.
Okay, let me check it really quick. Okay, so you have an error for the how you saved it. So you can't have any spaces in your file name. You should put like an underscore instead.
Okay. I did the same thing on the underscore, but then it still brings me on the second picture, which is like the MATLAB will not be able to run this file.
Well, that second picture, I just see spaces in there. So let me share my screen again.
Cause I copied like exactly what you did. It just didn't like it.
No, it should work if you don't have a space. Okay, so at least how I saw your picture, you had spaces. So instead, you should do this is my title like that, if
Okay.
that's your file name. So since Joshua brought that up, MATLAB, if you're saving a file, it can't start with a number. It has to start with a letter. It also doesn't want you to have spaces. So if you type in this is a file, it's not going to save that file because you have spaces. So you should instead put like an underscore or dash, something like that. And also you can't, or it's gonna throw a fit if you save it as some kind of function that's defined in MATLAB. So if you saved it as like legend and that was your file name, it would throw a tantrum for that. So just make some unique title for whatever or some unique file name, and then it should be fine. Okay, Kevin, any idea why my legend is missing the line and is also not boxed? Are you saying this little line here that is shown in the legend? Okay, and then you're missing this outer box, the black box. Okay. If you have, do you have code earlier on in your script? Because if you have code earlier on in the script and you defined the legend earlier, you might be getting an issue with that. So you could instead, for this one, you can type legend 2. And then what you have to do legend 2 equals legend and then run it. And then that should work now. If you have everything typed in like I have it. So you could try that out. Okay, but if anyone else has that kind of same issue, again, just assign a variable for this legend if you have some more legends that were defined earlier in your code. So do like legend2 equals, and then we're going to use the function here, legend, type it all out. And this time we have to suppress it, because if we don't suppress it, then we see these kind of properties here. So we're just going to suppress it. Okay, so I think I was talking about adding another function to be plotted on the same graph here. So right now we just plotted one function, and let's say that we want to plot y2 as well, which is sine times 3 of x. Just looking at this, we might have some issues actually. So I'll actually do, let's make another plot that's similar to what we first had. So we'll do e to the 0.2x minus 3 times x squared. Okay, so we have one line here, which is plot x comma y. And that just gives us this plot here. But if I also want to plot y2 on the same figure or the same graph, we have to use the kind of argument here, hold on. So once we type hold on for this figure, it's going to allow us to make another plot. So now we're going to type in the plot x comma y2. And now because I'm done with all of the functions that I want plotted on this graph, I'm going to type in hold off. Now if I run the code, then we see that we have both functions here that are plotted. Of course, I didn't update the legend, so we only have one thing that's in the legend. So let's update this so we can have the other plot as well, or the other function. So I'll type in e to the 0.2x, 0.2x minus 3x squared. Now if I run that, must have it valid interpreter syntax. What did I do wrong here? So maybe I need to add on the interpreter as LaTeX, and maybe that would, oh, I didn't have a curly bracket there, that's why. There we go. Okay, and now we have both of our functions that are defined in this legend. So Kevin, I don't know if you fixed your issue or not, but if doing legend2 equals legend and then, all that stuff, if that didn't work either, make sure that you're specifying which figure you have as well. So in this case, I have a new script, so this will just be my first figure, so I'm going to call it figure 1. Okay, so that's a pretty good review. Okay, Kevin, yeah, just stay around after class and I can help you out. Okay, so that should be a decent review for what we learned last time for plotting. Okay, so how to save a figure. This is a kind of a big one. In my labs, I have a pet peeve for how people save figures, I'm not gonna lie. So let's talk about how to save a figure properly inside of MATLAB. So we have our figure right here. And what I see a lot of people do is they'll go into like the whatever screenshot app that they have, and they'll just screenshot this box right here. They'll just basically, start right here and take a little screenshot like that. And that's not good. Don't do that. It looks bad. So what you want to do is go to File, and you could go to Save As, and then you could specify a JPEG or a PNG, but I don't recommend that. We want to instead go to File, and then we want to go to Export Setup. And once we go to Export Setup, that's going to give us more options that we can have for exporting our figure. So right now, we're in the size panel here, and we can specify the width and the height. Right now they're on auto, and then the units, either inches, centimeters, or points. I typically leave all of this the same. We can actually change the size of our figure in our code. That's something we'll talk about later on. But the main thing that I do inside of here is I go into rendering, and then I'm going to change the resolution. So instead of auto, we're going to go to 300 dpi, so that's dots per inch. And then we're going to export that. But let's talk about the other stuff they have. They have fonts. Again, I pretty much always leave this the same, but you can change the font scaling, or use a fixed font size. You can change the font type, the weighting of it, and the angle as well. But again, I pretty much always leave that the same. And then you can change the specification for the lines that we have in the plot. Okay, Eric, didn't see how I got here. So basically you want to run your code. You're at your plot right now, and then you're going to go to File, and then Export Setup. Okay, so again, all I'm going to change here is the resolution. So I'm going to go to 300, and then I'm going to click on Export. Also down here, you can actually save a custom kind of template that you want. So I can, change a lot of things here, and then I could just make whatever name I want, and then I could press save, and then we will have all of our options right there for whatever we saved. Okay, so resolution, 300 dpi. Again, that's all I actually changed right now. Then I'm going to click on export, so that's just export right here. And so by default, this is going to be saved as a .fig, so that's a MATLAB figure. So that's basically this right here. That's the figure. If you're typing a report, you don't want to save it as a .figure. You want to save it as some kind of image file extension. So meaning like a JPEG or a PNG, or even better, a vector. So .svg here, that's a scalable vector graphic. A vector graphic, basically, if we zoom in and keep zooming in, the resolution is going to stay the same. There's not going to be any kind of blockiness to the figure. So if you can save it as a vector, I would recommend that. Or something that's still good is saving it as a PNG. And you can do that. So I'm actually gonna, I'll just save it here. And I'll call it class example. And then we'll save that. Again, you see I put in an underscore. That's just by my own convention. Here it doesn't matter if we have a space or it shouldn't. Because all we're saving here is an image. So I'm gonna save this right now, and then so it just exported the file. So now all I have to do is press OK. And now I'm actually gonna go ahead and open up that file. So I'm gonna go to where I saved it. So yeah, here's the file right here. And if I open it up, make it full screen, we see that the resolution is still, it's pretty good. Let's actually zoom in. And you see, once I zoom in though, we start getting these kind of blocky lines from how our plot was made. So part of that is just an inherent issue with our step size. So we can make the step size even smaller to make it more smooth. Or if we saved it as an SVG or a vector, that would maybe help out as well. So you see, once I zoom in on 400 here, we see that it's starting to get kind of pixelated. So I'm going to go back to MATLAB, and I'll actually also export a vector. So I'm on my figure here, and I'm going to go to File and then Export Setup. Then I'll click on Export. So my resolution, that's still at 300 dpi. Then I'll click on Export. And then I'm going to scroll down and click on a scalable vector graphic, so .svg. Now I can save that, press OK. Let's go back here. Okay, my image viewer it didn't like opening it up in my image viewer. So that can maybe be an issue when you have a vector. But right now it opened up in another program I have called Inkscape. But you could open up a vector inside of Microsoft Word. So that'll work. But see here, I keep zooming in on 400 and it's staying smooth. There's no pixelation. So this is something that's, really good if we want to put in figures in our report and make sure that the quality is still high. So the best option, in my opinion, is to export your graph as a vector, a .svg. Let's also zoom in on our plot here. And you see this time, I mean, come on, look at that quality. It looks so nice. Okay, there's a question from Fabiola. Should we save it as a PNG or .svg? I would recommend a .svg. I only mentioned PNG because one, let's actually look at the file sizes. Oops, I opened up a lot of stuff. So the file size of a .svg, the file that we saved was very small, but our PNG is 70 kilobytes and our SVG is 102 kilobytes. So technically the SVG is a bigger file size, but I mean, that's nothing. That's just a few kilobytes here. So I would recommend saving it as a .svg. But you might run into an issue if you use something like LaTeX. If we're trying to put a SVG image inside of LaTeX, you have to do some more work to make that work correctly. So that's just kind of an issue for me sometimes why I save it as a .png pretty often. What did I use to open the SVG file? So by default, my computer just opened up Inkscape when I was trying to open this. So Inkscape is a program. It's basically like Photoshop, but actually no, I think I'm in Inkscape. I was thinking I was in GIMP at first, but this is Inkscape. So it's some free software that you can get. I use it sometimes just to make some graphics for my lectures. So let me I'll open it up so you can see the kind of the splash screen. So Inkscape. Okay, couldn't even see the splash screen, but yeah, it's called Inkscape. I'm gonna put it in the chat. But on your computer, you might have had, one of your default image viewers. It could maybe open it by default, or it would open up in like Photoshop or something like that. What is that program to laser cut? Yeah, that would be cool. But yeah, if you have something like Photoshop or Adobe Illustrator, it can, or Inkscape, it can open up a vector. Okay, so that's how I would recommend to save your files. Again, don't take a screenshot here. That's like my biggest pet peeve ever when students do that because it just looks bad. Okay, and I have all of those steps outlined in the slides as well. I only saved it as a .png. I also say as a vector file, but I'm showing in here just a PNG. Okay, so here I'm showing multiple figures at once. So basically, that's how I typed out figure 1 right here. Geez, it's already 10:40. I thought we were going to do a lot more today. Okay, this question, Karen, if we export it and we save it to our desktop, or do we have to save it in MATLAB files and then get it from there? So, no, you can just save it. Well, it depends what you want to do, right? So if you just want the figure and you want to use that in a report or something, just save it as a PNG or a vector. But if you want to go back and edit something in the figure, just make sure you have your script file saved, and then you can open that up and just run the script again, and then you can modify the figure. Or if you want to access that figure faster, you could save it as a .fig. So then you could just open up that .fig file, which would be this right here, and then you could, modify stuff in here. So yeah, you could just save the .fig, yeah. Okay, so multiple figures at once. So right now I typed in figure 1 and that it, once I ran the code, it showed the figure that we had. Let's say down here, I have a whole new plot. So let's plot x comma y, and we'll do y2. So if I run this right now, I'm going to run the code, and I only get one plot that shows up, which is that plot that I just made. It's doing plot x comma y2. Sometimes we want to see all of our figures at once, because we want to, either just look at them all or maybe compare some of them. So right now it only plotted or it only showed us this plot right here on line 24. That's because I didn't specify that this was, a whole new figure. So plot x comma y2, it overwrote this entire plot here. So if I want to see both of them at the same time, before this next plot, I'm going to type figure and then 2. I could also type figure 10 or whatever I want, but I'll call it figure 2 because it's my second one. Now if I run it, this time I have both plots that show up at once. And then I can, do some visual comparisons if I want. Okay, so just make sure you're kind of doing some bookkeeping here and putting figure 1, figure 2, and so on. All right, gotta keep an eye on the time now. Again, I didn't think we were already this far along. Didn't really do much. Okay, so talk about the grid command. So if we type in grid, and that's it, it's very simple here. There's a question. So, technically, well, first I'll read the question. So by putting figure, does MATLAB know to plot both at the same time? Technically, MATLAB, even if I don't put figure, it's plotting them. But then this other plot, figure 2, that overwrote the output for that graph. So yeah, if we want to have both of them at the same time, I guess I should say, if we want both of them to show up at the same time, then yeah, we have to put in a figure. Okay, so the grid command is very simple. All we have to do is type in grid. So that's it. That's just another kind of argument that we have within one of our figures. So if I want to have a grid for figure 1, I can just put it at the end here. Just grid. There we go. And then if I run that plot, then you see figure 1, it has a grid. Cool. Figure 2 doesn't because I didn't specify to put a grid. And it's going to make a grid based off of the tick marks that we have for our figures. So we have ticks for 0, 5, 10, 15 on the horizontal axis. And then on the y-axis, we have negative 1200 to 1000, 800, 600, 400, so on. All right, so that's how it's going to make the grid. And if I zoom in, you see that it's dynamically going to change the tick spacing that we have, and MATLAB will update to have that kind of corresponding grid. All right. Something that I'm actually looking into is an app basically, or an extension for MATLAB that can kind of improve the quality of these plots. So, when we were zoomed out here, this grid is pretty light. So there's an extension called export.fig, and there are some improvements for plotting. So I'm gonna look into that a bit, just because it might be of use to some of you in the class. Okay, so that's how we can put a grid. I just closed out of my lecture. Okay. I think I had a few other ones now. Okay, so that's a grid. Some other things we can do is adjust the axis of our plot. So let me run our code again. Okay, so here we're going from -5 to 15 and -1200 to 200. So I can adjust the axis that we have, or what's the range for the axis that's plotted. So I'm going to comment this stuff out here. So I'm just highlighting it all and pressing Control R, and then it highlights or comments out both lines. So for figure 1 here, I'm going to change the axis. So again, by default, we're going from -5 to 15 on the horizontal, and then the vertical -1200 to 200. I can change those limits by using the axis command or function. So I'll type in axis, and because we're using a function here, we got to put in a parentheses, and then we're going to specify our limits here. And for the limits, we're going to use brackets. Okay, so we have to use a bracket, and our first kind of argument is going to be for the x limit. So we'll do -5, and this time we're going to go to 20. So we're going to go from -5 to 20. So this is x min, and this is x max. Then we're going to specify the limits for the y-axis. So we'll do -1200 to, let's do 220. Okay, so now if I run this, it's going to update for our new limits. So I just ran the code again just by pressing F5. And now we see that this is going from -5 to 20 on the x-axis, and it's going from -1200 to 220 for the y-axis now. So maybe sometimes this would be of use if you kind of want some little like a border or some kind of buffer range on the limits of your plot. So that's something that can be of use, or it can be of use if you want to be consistent if you have multiple figures. So we have this plot right here. Let's also have figure 2. Let's plot that as well. So if you have multiple figures, let's say you have different data sets that you're plotting. If you want all of them to have the same range just for better visual comparison, you could do that by specifying those axis limits. So let's just copy this and we'll paste it in here. Let's also put in a grid. Now if I run this code, now both of them, they have grids and they're on the same range for the axis limit. So we have -5 to 20 and -1200 to 200. So that can be a nice convenient way for us to kind of visually compare some stuff.
Professor, can we also like make the lines spiral, like instead of it like curving inside?
Yeah, but that would just be a whole different function.
Oh yeah.
So we're actually going to plot something that's kind of unique like that in a few slides. Okay, so we can type in some other commands for specifying our range for the axis, or how we have the axis kind of formatted. So one of them is axis square. I didn't do this beforehand, but I imagine it's just like that. Okay, so this is actually kind of useful. I got an error saying that square requires signal processing toolbox. So I guess we need to have a toolbox to actually use this. Let's actually type in just axis here. So then I'm going to click on more help, and we'll see what they say for the style. Okay, so style is a predefined style to set the limits and scaling. Let's see if they have an example. So, in this case, I never even tried axis square, so I'm not sure how they actually specify it here. So let's see if they show it. So style might be different, like where it's like specified in a different way. Okay, so I don't see it off the cuff, but let's try defining this. Oh, here's square right here. Okay, so yeah, we need to just do axis and then just square. Axis, gotta type it correctly. Still didn't type it correctly. There we go. Okay, so if we're typing an axis square, then we don't need to use parentheses. So yeah, so our syntax, obviously matters. So, in this case, I didn't know what the syntax was like, so I just typed in axis and a parentheses, and then I waited for this to pop up, and then we can click on more help, and then we could read the documentation just inside of MATLAB, and that can often be very useful if you don't know too much about a function. So I'll do axis square once again, and then this plot, it has a square kind of axis limit for us. Okay, and then we have one more, just axis auto, or we have axis equal. So axis equal, that's going to scale our factors and tick spacing to be equal on each axis. So here, that looks absolutely atrocious. So, we want to use that here. But maybe sometimes that would be useful. So just something that's good to know. We might have time for one more thing. Actually, for this one, I'd want to talk about it next time. So we didn't, cover too much today. I wanted to cover more stuff, but that's okay. I at least reviewed how to plot stuff. So I hope all of you understand how to plot stuff, in a more confident manner than maybe you had last time. Because this will be a big part of our project. And the project, it's kind of flexible when we get around to it because we have to finish our plotting chapter first. So I don't want to rush through it, but we're going to finish plotting and talk about how we can import data into MATLAB, and then I'll assign the project, and it'll probably be like a week long that you can work on it. But we're going to get to that once we finish plotting. All right, so it's 10:50, just about. So before we basically leave for the quiz, does anyone have any questions on what we covered today?
Could you explain again what axis square is and what axis equal is?
Sure. So if we do, let's actually just plot it first, just like we have it here. And I'm gonna comment all of this out. So if I run this right now, oops, I took out X. Okay, come back and Y2 as well. Okay, so if I run this right now, this is using just auto scaling for the axis limit. So MATLAB, they knew, okay, I have an X domain that's going from -5 to 15. So most likely I want to have the range for our x-axis from -5 to 15. And then we have our function y2. And it's looking at those values that were computed in y2 to kind of automatically decide what kind of scaling that we want here, or what kind of axis range that we want for the y-axis. So it's doing that automatically. But if we do axis equal, or let's actually first do axis square. I think that's a bit easier to kind of understand. So if we do axis square, that's now just gonna kind of constrain our figure to be a square. So you saw that while our axis range is still different, it's from -5 to 15 and -7 to 100 this time. Our image here, it looks basically just like a square. So the axis range was constrained to give us this kind of square plot. And then axis equal, if we run that, this time it's making both of our ranges the same. So we have 0 to -600 to 0. And we have -400 to 400. So maybe I should have said the same. So this one I would actually need to look into a little more just because I never really use it. But if we look at the documentation, and I'm going kind of fast, but it's because we're almost going to have our quiz. If I go to axis equal, I think that was at the bottom. Axis equal, okay, yeah, so it actually is what I thought. They're going to use the same length for the data units along each axis. So each axis range is going to be the same length. We might have different values within that, but they're going to be the same length. So hopefully that clears it up a bit. I know it's kind of fast though.
Thank you.
All right, so it's 10:53. Your quiz starts in 2 minutes. So open that up in whatever browser. And again, I said it earlier in the class, but maybe some of you weren't there then. You can use MATLAB and you can use the slides because that's something that I can't, enforce you to not use because I'm not, with you. So you can use MATLAB and you can use the slides for the quiz. The quiz is 20 minutes. Hopefully it actually works right for the timer this time. And I'll stay in here to answer any questions. All right, so good luck. It's going to open up in 2 minutes.